For now, let's focus on this particular project, AntlrExampleVisitor, where we're going to consider the generated classes by Antler that are related to the visitor design pattern. For now, let's first of all create a new package for storing the so-called model classes. I'll justify why we need such class as opposed to just the predefined classes by Antler. Okay, there's a need for this. Right-click on the source and say New Package, and then we'll say Expression. Okay, and then we're going to create several classes over here. Before I go ahead and implement the classes along with you, I would like to talk about the design of these classes. Okay, let's go over the hierarchy over here, and this should be very familiar to you because you learned about the composite design pattern about having the inheritance hierarchy for recursive object structure. So that's something you may want to review from your previous software design course. But let's go over this particular design very quickly. At the top level, we have a class called program over here. Okay, let me change the color. We have a class called program. And the program at the top level has a list of expressions. And each expression member is of type expression. You can think about this particular class is abstract, unimplemented. And then under which we got several subclasses over there that can be instantiated. We have number, we have for example, it or she represent input such as like a 2, and also we got variable, for example, I, and also we got variable decoration. For example, you say I of type integer should be equal to 5, right? So somehow you would like the input like this to be turned into the corresponding model objects. And also we got modification, for example, 2 times I, and also we got addition. That could be maybe I plus j. So these are the model classes we are going to create, and then we're going to see how exactly this particular object structure should be related to the parse tree that we looked at in the previous tutorial video. And you might be wondering why we need these classes, provided that maybe the parse tree already itself is a runtime structure. Can we not just manipulate directly on the parse tree structure? That's the question I will keep emphasizing, that having this particular model object structure is completely under your control. On the other hand, if you try to only manipulate too much, if you rely too heavily on the parse tree structure that's given to you by Antler, that's kind of beyond your control. It's hard to debug when things get too substantial. Okay. Let's now go to Eclipse over here. Now that we understand the design, let's now program them quickly. Okay, so let me just follow the order I would like to follow. So now, first of all, let's create a class called expression. Okay, that'll be the top level. Under expression cluster package, I'm gonna have a class called expression. And this class is going to be abstract. Okay, I'll choose abstract. And over here, expression class, should we put anything over here? Okay, actually for this particular tutorial video, we are not really aiming for the best design. For now, I just wouldn't put anything here. Just like a placeholder, like a type for us to declare later. Okay, and then what I'll do is, so this is abstract, so this gives me a static type for any expression objects. And the next one I want to do is the program class. Okay, so now let's create a class called program. And for the program class, it's just a normal class. It should be implemented. So now let me just go to the program class and see what we should put there. The idea would be, as we see for the design diagram over here, so we should really say program should contain a list of expressions. Okay, that's something we're going to do. And then I'm just going to see what we should do, and then we'll do it together. First of all, let's declare attributes over here. And now, again, I'm not trying to aim for the best design. For now, I'm just going to break encapsulation. I'm just going to make the attribute public. So I explicitly say that this is not the best design. When you do your project or assignment, you really should aim for the best design. For now, for saving the time, I'm going to say just public attributes. Okay, so now I'm going to say list. So I'm going to use the list from the utility package and list of expression. You can see the expression here is the abstract class that we talked about, and the runtime object can be any dynamic type, can be any of the descending classes of expression, including variable decoration, and etc. And over here, I'm going to say expressions. Okay, so now this will be the only attributes we have. And then let's declare the constructor program over here. Okay, taking no parameter and this dot expressions, just initialize that to be empty. Initially just no expression over there. Let's say array list over here. Okay, for abbreviation we don't need this. Okay, that will be the constructor, and then the only mutator we have is we say void add expression and then expression e, and then we simply say expressions, which is a list dot add e. Okay, that's our program class, right? So now you can see very clearly the client-supply relation between program and expression. So now let's create all the descendant classes of expression. Okay, let's do them very, very quickly. Each one of them is rather simple, so we don't have to type too much. Okay, let's just type it one by one. So now the first class I would like to create is the number class. So I would say class number, and then the superclass should be expression. Okay, I'll say finish, and so now number extends expression, and then the only attribute I have is just number, num. So public, and then number for the constructor, just taking another number to create the number objects. This num is num. Okay, very easy to program. And now let's say I also want to, later on you will see the need to actually print out, to pretty print your expression object. Again, I would like to remind you that we're not aiming for the best design. To really do pretty printing, you may want to consider creating your own visitor hierarchy and then create a visitor for pretty printing. Okay, as you learned from the previous software design course. But for now, I'm going to do the worst design. Okay. Okay, so I'm just going to override the toString method over here. So how do I actually return the toString value for a number? Just return a value. So I can say return, and then I'm going to use a integer class to create out of the num, and then say toString. Okay, so that would be the number class. Okay, the next one would be I want to create maybe just the variable decoration. Okay, that just follow the logical order. Okay, so now for the variable decoration, I'm going to create new and then class variable decoration. And let's put expression as a superclass over here. And now for variable decoration, we got three attributes. We got public, string the ID, okay, for example I, and also public string the type. And in this case, just the like a keyword, the integer int, right? Later on, if you want to extend your project for this particular tutorial video, you may want to make the type of the type itself maybe another class, right? Another hierarchy. Okay, just a design suggestion. And also public, and you can say integer value. The value of the initial value for example, I of type integer is assigned to 5. So now, how do we do the constructor? So variable decoration, and then string ID, string type, and also int value, right? So I'm going to initialize all of them. This .id is assigned to ID. This .type is assigned to type. Also, this value is assigned to value. Okay, so now that's a variable decoration that we can also instantiate at the runtime. Of course, I haven't talked about how you can link from the parse tree that we saw in the previous tutorial video into model object structure. I'll get there in just a moment. Let's finish the implementation first. Okay, so now we're done with variable decoration. The next one will be, let's say, variable. For example, if you simply refer to I, assuming that I is declared, then eventually what we want to evaluate what I's value should be. So now I can say new and then class. Let's say variable over here. And then I want to extend it from expression. Okay, so now for variable, the only attribute I have is the ID. String ID. And then I can say public variable string ID over here. This .id is assigned to ID. So you might be wondering, for the variable declaration, should we override a toString method? Well, I would say for the purpose of my illustration, I don't need it. However, maybe you want to define that just on your own. But again, the best design would be to use a visitor pattern for the pretty printer. Okay, let me go back to variable over here. Okay, so for variable, for now in this case, for my purpose, I need to redefine the toString method. Okay, I'll say toString, and then I'll simply say return just the ID. Okay, that's easy. So now we got two more things to define. One is the multiplication, the other one is addition, and they look very similar. Of course, you could have pulled them up maybe into a common superclass, maybe called binary operation. But again, we're not aiming for the best design for this tutorial. Let's say we want to do multiplication, and then the superclass over here is expression. Okay, so now how many attributes should we have? Left and right, and each one of them, that's a recursive object structure. So this should be the composite. Expression, recursive case basically, and then expression. This is why you can build arbitrarily complicated expression from the model objects, and similarly in the grammar. Okay, so now what about a constructor? So multiplication, and then we have expression left, expression right, and then this left is assigned to left. And of course, feel free to use the code generation facility in Eclipse. I'm just trying to type myself. Is right. Okay, and then again, we also need to actually define the toString method to override it more precisely. And then what should we do? Well, in some way, the toString method presumably have been defined for the relevant expression, so we can call them instead. So it's just more like a recursive call. Left dot to string plus, in this case, the operator should be multiply, and then plus right to dot to string. Okay, like that. And then I'm going to define also the addition, which will be very similar. Okay, so I'm going to do some copy and paste in a moment. Addition, and then the superclass should be expression. Okay, so now there's a proper inheritance hierarchy structure, so I will just copy and paste from multiplication. Again, you could have pulled the common attributes up into a common superclass, but you can do it. So left and right, and so now rather than multiplication, that should be addition. And now for the toString, rather than star, I should say plus. Okay, so these are the classes. We got addition. So let's see how many descendants we have. 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5, and plus the program and also the expression, right? So we are now done with the expression package. We still have to add maybe one or more, two more classes there a little bit later, but for now we are okay. Okay, so what we have achieved so far is we have seen the design for our model classes, and also we have implemented them quickly in Eclipse in a separate package. So it's always nice to separate different concerns into different packages. So now the expression is basically the model package for all the logic about your application. ANTLR is only for holding generated classes plus the grammar specification file in the from the ANTLR. Okay, so now let me close all the classes over here. So now I assume you are familiar with this particular structure and what attributes are there in each class. So now I can talk about the connection between parse tree and also the model objects at the runtime. Okay, before I do that, I would like to just do one more thing. Okay, before I talk about how you can instantiate model objects. So now if you go back to your Eclipse project over here, you can see there are basically different visitor classes that's generated. So now for that, I'll just go over something very quickly with you. Okay, just to understand the structure and then to see how we can extend them. So basically, the blue ones are the one generated. One is called expression visitor, the other one expression base visitor. And these two classes are simply generic. Okay, so one expression visitor is an interface that's actually unimplemented, of course. Expression based visitor is an implemented class that's actually not abstract, and it implements from the interface. What we want to do later on, as I will explain, is to create two descendant classes under expression-based visitor. So one is called ANTLR2 program, thinking about this more like a transformer. So this class is going to go from ANTLR parse tree into the model object that we talk about, specifically the program type. And another visitor class will be ANTLR2 expression, and conceptually they'll be from the parse tree nodes into expression type objects. Okay, and these two classes we have to implement them, but we'll implement it only in the next tutorial video. For this video, we need to understand how can we think about the visitor pattern, and then how can we use a visitor pattern to transform from the ANTLR parse tree into our expression model objects. That's really important to know. Okay, let's go over that now. So now let me go back to the previous the slides over here. Okay, just over here. Okay, let's use this particular example to think about. Okay, so now just to get a big picture straight, the green one over here, this guy here, this box over here, this is a parse tree for this particular input program. Okay, so we have one decoration, and we have another decoration, and we have another expression. And that expression there is simply just overall is a addition, because the multiplication takes higher precedence, right? So that's why you can see over here we got a program which got 3 subtrees over here, right? Let's disregard EOF just for now. 3 subtrees, and then each one of them is the leaves over there. You can see the leaves. Okay, let me highlight the leaves. This is one of the leaves, and also I plus j multiply 3. So all the leaves together should really correspond back to the input program, right? That's something also we discussed in the class. Okay, just a very quick review. What we really want to achieve eventually is to say, when the generated ANTLR Java classes get back to us a runtime structure of this particular parse tree. And as I said, we don't want to manipulate directly on this parse tree. Okay? We do not want to manipulate, running out of space, manipulates directly upon this parse tree. I want to emphasize this because you could, in theory, you can do that and make everything still work programmatically, but it's actually unnecessarily complicated. Again, the ANTLR class structure is actually very complicated. I will only show you some useful features over there, but you will already realize it's quite more complicated than necessary. And then what we really want to do is to transform this particular parse tree structure at the runtime into the following object structure. Let me just go over it with you very quickly. Okay, basically the pink diagram over here is simply an instantiation of the design of the model objects that we just talked about, right? So now you can see all the class names should really match the title of the objects over here. Let's just talk about it very quickly. Overall, we have a program objects, right, of type program. And its expression list should point to actually 3 children over here, right? The first one corresponding to the first line over here should be a decoration. So I of type integer should be of value 5 initially, right? The second one, in a similar way, is going to correspond to the second line. So I of type integer is actually of initial value 7. Okay, that's the second line. What about the third line? The third line, because multiplication over here takes higher precedence over here. So that's why you can see overall the tree is an addition, because multiplication should be done first, right? That's something you should really note. So now when we actually handle the addition over here, addition objects, the left objects over here should be an expression, and that itself should just be I. You can think about this part should be the right subtree, this part here. And this one should be the left subtree, right? So this will be I for the left. And for the right is simply just another multiplication over here. Multiplication, and the left should be a variable j, and the right over here should be the value 3. Okay, So now this is kind of the object structure we would like to create for the parse tree. But how exactly do we do that? Okay, that's the question we want to answer. To illustrate the idea about transforming the parse tree provided by ANTLR at the runtime into our model expression objects, let's now consider a cleaner page. Okay, let me go back to a fresh page with the same example. Let me just talk to you about the principle. Okay, of course, for your particular application, you can feel free to be more creative and try to modify that a little bit. Okay, let me tell you for this particular case. I assume you already you try to review a little bit about how the visitor design pattern works. It's beyond the scope of this particular tutorial video, but I'll just tell you the outcome. Okay, it would be very ideal. Think about, remember what we said in the class. Every internal node, like a program, declaration, and also expression, for example, and also this, of course, the expression itself might correspond to either a plus, or it might correspond to multiplication, right? You can think about every internal node corresponds to somehow some variable type. And also every internal node should also correspond to some model class. For example, declaration over here correspond to variable declaration class. And the expression class of this particular kind correspond to the addition class in your expression package, and also the expression over here correspond to multiplication. Okay, so now in order to use the visitor pattern, it will be very convenient if for every model expression type you actually have a corresponding visit method. For example, we should have one method called visit declaration. Okay, and we should have another method called visit program, and also we have another method called visit expression, or it could be visit addition, right? Depending on how you define your visitor. And also there will be it will be very convenient. There's another one called visit multiplication. Basically, for every internal node, it corresponds to a model expression class in principle, and for every model expression class, we want to have a corresponding visit method to really convert from the node into the expression objects. So here I tell you the principle. Okay, I'll write it down here just to be very precise. So each internal nodes corresponds to an expression type. Okay, right? So this, you can think about this is ANTLR and this is our model concept. Okay, and then second points. For every expression type, we want to have a corresponding visit method. Which will do the following. You will simply, for example, you will simply go from declaration, as you can see over here, and transform it into variable declaration. And give you another example. Maybe given, let's say, oh, this is another one. Actually, this is another way to think about it. This one will correspond to maybe variable, right? Well, this one is also like in the parse tree is not really in the parse tree is actually a token. Of course, sometimes token can also become some expression type. In this case, it will correspond to variable over here. Okay, and another example would be maybe given this particular maybe variable j, you will turn that into a variable object. Okay, so these are different examples. So that's kind of the principle, 2 points you want to get straight. And now let's see, assuming that we got such visitor methods, and let's think about how it's going to happen at the runtime. So the way it's going to happen is going to be bottom up. Okay, you can think about somehow the leaves will actually be matched first, and then they will be used to build maybe a smaller subtree, and smaller subtree will be combined together to build a larger subtree, and eventually everything will be joined under the program. Okay, so now I'm going to use highlighter to actually tell you how things will actually work. Okay, so now first of all, let me just fill in all the details first. Okay. So maybe it's better for me to be consistent with my highlighter. So let me use blue over here. Okay. So let's say the first one to be matched would be, let's say the first one will be, let's say this particular I is I of type integer is assigned to 5. I is of type integer is assigned the initial value 5. In that case, when we try to visit this particular one, when we try to, let's say, visit decoration on this particular node over here, on this particular subtree, or you can think about on this particular node. In that case, it's going to return the corresponding object like this. Okay, I'll draw that correspondingly. What that will do is it's going to be this particular variable decoration. Just this one. And then when we create it, we're going to fill in I and also integer and also 5. Okay, that will be the first object to create at the runtime. Okay, just notice that I'm just using highlighter to denote the order of object creation. And the next one will be, let's say this one here, the second variable decoration. And it will be very nice if we actually got visit decoration on this particular node. Let's say if we call that over there, so let's say we call visit decoration on this particular internal nodes. What that would do is going to actually create this particular objects at the runtime, and then we're going to fill in j integer 7, j integer and 7. You can think about by visiting each internal nodes is going to create two objects that are not really connected to each other, but hopefully once you get to the upper level for the visit, you actually will join them together. You will see exactly we'll do that in the coding. I just want to make sure it's going to make visual sense to you before I try to do it. Okay, and then the next one will be, let's say here we might see this I here. We might also see this j here. We might also see this 3 here. I, j, and 3. It will correspond to these three objects, I, j, and also 3. And then let me put it out. So that'll be I here, and also we got j here, and also we got 3 here, right? So when we visit, for example, this will be visit variable on this particular node is going to return this particular variable objects. And then let's go a little bit upper level. And now when you try to visit, let's say this particular expression, let's say multiplication. So it would be very nice if you got visit multiplication. If you say visit multiplication for this particular expression node, so now it's going to create this particular one. Not only that, it's also going to link to the previously created two objects. One is this variable, the other one is the number. Okay, and now we can also visit this particular expression node, in which case it corresponds to addition. So it will create this particular addition objects over here, and not only that, it's going to join the left to here and the right to here. Okay, you can see the way we build a tree is very similar to how we build the model objects. Okay, hopefully you get the point. And eventually, when you say visit program on this particular node, the root node, when you do that, it's going to create this particular program objects, and then it's going to set its 3 children accordingly. Right? That's how we build an object structure. So you can think about there will be many instances of the visit method that we have to call, either to visit the decoration, visit the variable, or to visit number, or to visit the program. We're gonna see that lots of that, and the order in which we call the visit corresponds to the order in which we try to build a tree, bottom up. Okay, that's kind of the remark I would like to say. Okay, having this in mind, so now let's see what kind of visit methods are actually supported by ANTLR generated classes. Let's take a look. Okay, so what I would like to point to you is this. Remember we said before this particular hierarchy. So there is a class called ExpressionVisitor over here, which is generic. Let's take a look at that class first and see what visit methods are available. If you go to that particular class, so ExpressionVisitor. Okay, if you look at that, under ANTLR, of course. You can see, first of all, it's an interface over here. So what classes do we have? If you go to the outline view, you can see we got visit proc, visit decoration, and visit expression. So now I have a question for you. Can you tell me why ANTLR would know we should generate exactly these 3 visit methods? One is called visit proc, the other one is called visit decoration, and the other one is called visit expression. More precisely, why such spelling for the visit method? How does ANTLR know? That's a question. Okay, and one thing to note, you can see this particular visitor class over here also is generic. So the type over here tells you whatever T you commit to here, it can be program, any of the types that's in our expression package over there, right? It could be maybe program, or maybe it can be expression. You're gonna see these 2 cases. So we can instantiate this particular class by instantiating T into program. We can also instantiate this class by instantiating T into expression. Okay, that's what we can do. Okay, so the reason that you have program, you got decoration, and also you got expression here by default is because, let's go back to our grammar file, which we did in the previous tutorial video. If you go to your ANTLR folder and then remember this expression.g4, if you look at that, how many production rules we have? Exactly 3. They are called proc, decoration, and expression. They just capitalize it. Okay, so by default, if you didn't do anything customized, you would just get visit proc, visit decoration, and visit expression. Exactly like what I said in the previous slides. You have one method for visiting program over here. You have the visit proc, which is going to handle things like this. Okay, proc. Also, you got visit decoration. Also, you got visit expression. But now, as I also try to explain, how do I know? Sometimes I need to instantiate addition, and sometimes I want to instantiate multiplication. It really depends on which production rule I'm talking about, right? If I'm matching this particular production rule, I should really create a multiplication object. If I'm matching this particular one, I should really create a maybe addition object. If I'm matching this particular one, I should do variable, and this one here, number. So it would be very nice if I can say I create a visit method. More precisely, I want the ANTLR tool to generate a visit method for every alternative. In this case, for example, how can I do that? Okay, so let me just say one more thing before I talk about how we can do it. So all I want you to realize is we have exactly 3 visit methods over here, and their name simply just comes from the variable name in the grammar file. Okay, but now we can customize it. We can do it. And notice that the node, you can think, let's say visit program. What's the type of this particular node at the runtime from the ANTLR side? It is of this particular type. It's expression parser dot programming context. So this is the type. And also we got another one called decoration context, another one called expression context. So these classes may not be as easy to work with as this particular hierarchy with all the expression, variable number, the one we just have seen. So now this is, again, emphasize my arguments. So in order for you to really build a large project for your compiler, you really want to have a good design for all your model concept as using the composite or composite pattern, or possibly in combination with client-supply relationship, rather than just working directly with the predefined classes over here provided by ANTLR, for example, programming context or expression context, and etc. Okay, that's my point. So now, one more thing to say. According to the diagram over here, there's another class we want to look at, which is expression-based visitor. So this class here implements the interface over here. Apparently, it will implement all the 3 methods that we talk about. I just want to show you very quickly. They just provide some very default implementation. If I go to expression-based visitor over here, you can see, again, if you see the outline view, we got, again, these 3 methods over here, and this class remain to be generic. So it hasn't really committed to what type it's going to return, but we will when we define our own visitor classes. You can see over here, they simply just say override over here, right? They try to redefine, and then they simply just say visit children over here. Okay, very default implementation. You don't need to worry about how this works for now. Okay, we're gonna see exactly how we can build our visitor methods, and the way we implement our visitor methods will be just like how I illustrated visually a few moments ago. Okay, like how we build objects based on the visit results. So now let's see how we can regenerate all the visitor methods to be the ones that we really find convenient. So what I want to do is show you back to the grammar file over here. So what we want to do now is to add so-called labels besides the production rule. Okay, let me just show you all the details, and for now you should really open up your grammar file and let's do it all together. Okay, let me just go to look at my reference over here. Okay, so the first one I want to do is for the start symbol. Okay, the syntax for that is, besides this particular alternative, well, you only got one alternative for the program. I'll say # and then program. What you can expect later when we regenerate the parser code, you're going to have a visitor method called visit program. Okay, and then for this particular one, I want to say maybe decoration. Okay. When you got multiple alternative over here, ANTLR require either you don't specify any labels for them, or you gotta specify labels for them all. Okay, for now I'll just do that. Okay, so now I can really customize and make my visit methods more meaningful and more fine-grained. Okay, and then so for now for this one here, I would say multiplication. It makes sense. So later on I will have something called visit multiplication, and also addition. And then I have another one called variable. So I'm going to have a visit variable method later. And also I have number. So I'm going to have visit number later. Okay, so now I've added 1, 2, 3, 4, 5, 6 labels. So that means I'm going to expect to see 6 different visit methods whose name will correspond to them. And then they will also make sure the type, the context will correspond to the corresponding node in the internal nodes in the parse tree. Okay, and then we're going to see exactly in the next video how we can program these visit methods. They are not hard. You just got to understand, visually speaking, how you can relate each visit methods to the construction of such object structure. That's what you're going to see. But I will advise you may want to review the visitor design pattern that you learned in the previous software design course. I will highly recommend. Okay, so now that we're done with this, so what we should do now is to regenerate all the parser code. Okay. So now let me make sure I'm in the right place. So now in the command line, I'm now in this particular visitor objects, visitor projects. I'll now go into the source, okay, and then ANTLR. Okay, now I want to regenerate all the classes over here, right? So what I want to do, assuming that I'm not going to use a grun at the moment, so I'm not going to recompile in this folder. Eclipse will just recompile for me, provided that I refresh. So now I'll say ANTLR4, okay, just type it out right correctly, and then now I'm talking about the visitor option. So visitor, and then expression G4. Okay, I'll do that. Okay, so now everything is regenerated. Of course, if you're using a Linux-like environment, you can simply check the time frame, the timestamp. It will just be the current one. Okay, anyway. So now I will go back to Eclipse over here. In order for you to see the updates, you have to actually, let me just go back to Package Explorer over here. So now let me just refresh. Okay, if I refresh, you can see everything compiles, right? Somehow it shows a little bit inconsistent with the error messages, but that's because I didn't refresh. Okay, make sure you always refresh after regenerating all the ANTLR related classes. So now let's reaffirm. Okay, again, if you recall this hierarchy over here, we want to see all the 6 methods corresponding to our labels in not only this class but also this class over here. So we can create 2 subclasses accordingly, which will be done later. Okay, so now let's go back here. First of all, let's go to the interface. So that would be expression visitor. If I go there and I see the outline view, you can see 1, 2, 3, 4, 5, 6. And not surprisingly, you can see we got visit program. And this again corresponds to the program over here in the grammar file. And also we got visit declaration. Not surprisingly, you can see this declaration here, and etc. And notice that the type for the parameter, one is called the program context. So program context basically is referring to this particular internal nodes program over here. Okay, this one here. Okay, let me write it down quickly. Basically, this guy here, program over here, is really of type program context. Okay, and similarly, so you can see another one is declaration context. So that'll be for declaration. So now you can think about the type for this particular node is declaration context. And etc. Okay, of course you have a type for the variable, and also you have a type for also addition and multiplication, right? And etc. Okay, so now we got all these 6 visit methods. So now we have them regenerated, and now let's also take a look to see the other class. And remember, again, I should really remind you of the hierarchy. We have confirmed that this particular interface got 6 methods in the regenerated code. When I confirm, also this particular class that's not abstract also got the 6 methods. It should, right? Let's confirm. If you go to expression base visitor, so this is the class that's not abstract. You can see this class over here implements the expression visitor. You don't need to worry about this particular class. It comes from the jar file, which is not available to you. Okay, we got a visit program. If you see the outline view, again, we got the same 6 method here. 1, 2, 3, 4, 5, 6. And again, you can see for this particular class, it is generic, which means whatever T you decide to commit to when you declare something concrete, every return type of the visit method is going to be the same T. For example, if I instantiate T to be program, in that case, visit program is gonna return program. If I instantiate T to be expression, for example, then visit declaration is going to return an expression. Dynamically, it will be a variable declaration object. Hopefully, everything still makes sense to you. Okay, so now, hopefully for this video, you can see the big picture over here. I would suggest before you go on, because in the next video, we're going to start implementing the 2 visitor classes. One is to convert our some internal nodes into program, and another class will be converts some internal nodes into expression nodes. And we're going to see exactly how to implement those. But as long as you can get intuition from how we build a tree, like what I have illustrated previously, I think the implementation should not be so hard. Okay, review that before you go on.